Hello, it's Eric Lee again, and one of my crazy attempts at explaining um, the process of certain physics phenomenon. And I just love challenges, and I love puzzles, and trying to solve them, whether it's like conspiracy theories or in this case scientific matters and whatnot. And this one that I'm going to try to explain is the fine structure constant. Yeah, it's like, according to all the videos I've seen, which is only like three, it's a mystery that um, all physicists just don't understand. For instance, uh, they have no idea what it is, but it exists, and it's a constant through pretty much the whole universe. And they say without this constant, the universe wouldn't even exist. And I can explain why. I believe I can. And I'll give you some quotes. Like there's a famous Nobel laureate, Wolfgang Pauli, Austrian theoretical physicist. He lived from 1900 to 1958. He said, "When I die, my first question to the devil will be, what is the meaning of the fine structure constant?" And then the famous American physicist, theoretical physicist, another Nobel laureate, Richard Feynman, he said, um, it's the fine structure constant is a magic number that comes to us with no understanding. And apparently, it's still like a total mystery to this day, to this moment. But I'm going to try to explain what it is, believe it or not. Yeah, this crazy guy with uh, 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 barely a 2 year science degree and plenty of hours of reading, mm, just tidbits of information and watching tidbits of documentaries. Anyway, here are some of the equations. Uh, it's the number is the ratio 1 over 137. And I put it on my Pinterest, Eric Lee, the rubbish writer, in the section called Time. And it's in time is faster than the speed of light. And I still quite haven't explained that yet in like, uh, what would you call, like, a defining manner, which I tried to kind of explain in like these number of videos that I did, but I don't know if I really did such a great job. I know these videos kind of suck, and there's no any kind of animation or nothing like that. But if you could just hear me out and just uh, see if I'm just a quack with some crazy ideas, or if some things I'm saying absolutely make sense. And I think, according to some of the, um, what do you call it, the ratings on my videos on Pinterest, not on YouTube. I guess it's a totally different audience. I think Pinterest has people that are more interested in new ideas and crazy ideas, even on whatever they're interested in, whether it's physics, science, science fiction, anything. I mean, Pinterest is just super. I think it just covers all range of interests. And anyway, going back to this fine structure constant, um, basically, yeah, without it, the universe wouldn't exist as we know it or exist at all. And when I saw this number, 1 over 37, it kind of just like, I had this kind of aha moment because, as I explained through some of my previous videos, we're talking about like basically positively charged energy versus negatively charged energy, uh, uh, superpositioning of quantum particles, blah blah blah, and um, and this is my crazy humble attempt at explaining what the fine structure constant is, and I think it has some semblance of what would you call it, good information, or is pointing in the right direction at least, if not hitting the nail on the head. So please listen to this explanation. I'll try my best without all too many uhs and too many does, as I say. And the thing that came straight to my mind when they mentioned that ratio was I was for a while an auto technician for a while, and they had this ratio called the stoichiometric ratio, and what it is it's the optimal ratio between fuel and air to give the most optimal combustion, in a sense, production of energy. And so basically, I said, well, wait a minute. If it's 1 over 37, that's basically 1 over 14 with a slight variance in number. And yes, the physicists say the number can vary to a degree depending on the level of energy we're talking about. So um, I said to myself, well, isn't that odd? And I said to myself, well, okay, let's see if I can do a little a brain, um, you know, uh, what do they call that? Brain jogging or whatever. um, brain experimentation, a thought experimentation. I mean, I'm sorry, a little nervous because I think I am onto a little something here. And so basically, as I said, the 1 over 14 represents, this is the 1 is representing 1 parts per million of petrol or fuel, and 14 is how much oxygen parts per million versus the fuel you have to have proper combustion. So um, and it says here, I wrote down optimal combustion takes place, and this is 1 parts per million of fuel versus 14 oxygen. And uh, what do I have here? I'm trying to remember. This is so complicated. I was actually breaking out into a sweat trying to figure this out. And maybe I haven't done a complete job, but it's getting kind of close to um, I think what they're trying to say in physics, or trying to understand, or what nobody understands. I'm trying to figure out uh, something crazy here that I might just be crazy trying to figure this out. I don't know. But like I said, try to keep a sense of humor. And anyway, let's see here. I try to do some like calculations here and find some correlation. And I even multiplied it by pi to see what would happen if it was in like a confined like circumference state. And I thought I had found something, but I did it late at night and I can't remember what that was. But anyway, going on with this stoichiometric pressure, or constant, I should say, of giving the um, oh my goodness, the most. Hold on 1 second. I'm sorry. Yes. So I'm sorry about that. I had to pause the video for a second. I was trying to gather my thoughts. This is like a little diagram of like when you're within the ratio. of optimal burn or combustion of a what's occurring in the cylinder of your engine. Uh, this is the optimal ratio of fuel versus oxygen here. So when you get too less of oxygen, then no, I'm sorry. When you get, oh my goodness, I'm having trouble reading my own writing here. When you get too much oxygen, I'm sorry, too much of a ratio of oxygen. Let's say this was like 1 to 20 or 1 to 30, then you get what's called a lean burn condition. And what happens is you'll get too much positive pressure and energy built up. And, and what happens is your exhaust manifold in the combustion chamber will literally get extremely hot to the point where it can literally melt down your pistons, and your exhaust manifold will glow red hot. And if you go the other way and you increase this ratio up at the top to a 2, or you decrease the, let's say, the value here, then you'll get too rich of a mixture of fuel versus oxygen. So you have less oxygen and more fuel. And more fuel can be more energy, basically, right? So you end up eventually with dumping fuel onto, um, this whole combustion process. You'll completely put out the combustion. You'll have no energy, and you'll just get negative pressure, negative energy. And just keep that thought in mind. And so basically, um, my whole premise to my theory here on what defined structure constant is that this one, um, in the 137, uh, I made the symbol. It's a symbol in the Cyrillic alphabet, which is F, and it's kind of like a infinity symbol with a line through it. And I chose that symbol because I don't know if it exists in physics already or not, but I chose it because I'm showing like one particle is positive, one particle is negative, and then the stick between is this potential energy that I was speaking of throughout my videos, which they have yet to detect in the Hadron Collider. They're going to make one that I think that's double the size to detect even smaller particles and what have you not. And I think I said there was one physicist on YouTube saying he's going to find that particle, soon, eventually. Anyway, so my whole theory here is that, okay, I said 137 is equal to the uh, number of quantum fields that dictates how this potential energy, which is represented by the 1, is transformed into matter or kinetic energy at its optimal configuration for all universal constants or matter to exist. Um, and that it applies, of course. Matter is energy, so basically, yeah, it relates to everything in the universe, as the physicists say. Uh, and what is the, so I think the 1 represents this uh, uh, representation, that I made. That this figure represents the energy, because going back to the combustion of the engine that takes place, it just totally sparked off this whole crazy idea in my head. And anyway, what's happening, I believe, is the 137. So the one is okay. I'm sorry. The one is the is energy or potential energy, and I made this symbol for that. And they recently found that the Higgs field um, uh, it's an electromagnetic quantum electromagnetic field that creates these particles called bosons. And basically, let me see. I said the Higgs field equals boson. Uh, and then, oh, okay. So basically, these are notes I'm trying to read. Um, uh, Basically, the more of these potential energy particles are introduced into this Higgs field, or perhaps the 137 is basically dealing with how many fields that may exist, and it's like a circle within a circle within a circle within a circle, and the smaller the field gets, the smaller the particle. So, and each field has its own vibrational frequency, and it's able to um, create you know the effect we see from like an electron turning into protons, and there are different sizes to these quantum particles, as you know, and I think the boson is one of the smallest ones they've detected. It was very elusive, and because of that. And my thing is that it could be just one field, and maybe the 137 represents how many uh, units of these um, energies must combine in the Higgs field to form perhaps an electron, or it could be we have 137 different fields, and maybe it could also represent even universal constants. Well, they would be universal constants if there were fields. Anyway, basically, um, and I'm just laughing at myself because this whole idea is just kind of just came into my head, and it sounds completely crazy, but I think I could be onto a little something here. Anyway, these particles are created, and basically uh, they go from the smallest, then to the largest, and then to the next largest, and these are like all the different parts of the quantum particles, and it can go all the way out to 137, uh, roughly 137 layers, or magnetic fields or electromagnetic fields at the quantum level. And um, each field, I said, each quantum field layers, each field dictates what form of the quantum matter is formed by its frequency and magnitude. These fields are created by the interaction of energy fields together to form matter, and thus all. Um, oh my goodness, it's getting dark. Uh, Regulates all processes of energy and matter in the universe. So yeah, it basically ensures that you know uh, everything will work at its optimal range. For instance, like let's say there was 160 different fields, and then you would have like extra material in the atoms, or extra electrons, or extra whatever quantum particles. Well, then you'd have like crazy things happening, and you would have absolute chaos, and it would even affect the negative and positive effects of what's happening in the universe as positive energy and negative energy. And my next video is going to be probably on the electric field, electromagnetic field, and how. And I'd like to get into this thing with this video about electricity. But anyway, this is my whole thing on the Higgs field. I mean, and the not the Higgs field. I mean, the Higgs field has probably something to do with it, and the interaction of all these particles uh, and all these quantum fields are near 140 to 137 different types that are yet to be discovered, I believe. And or it could be totally something else. Maybe it has to do with 137 or 140 constants in the universe. But then that's still, if you have a Higgs field, well, that's a constant. So I don't know. I mean, these are processes that are occurring that ensure, as I say, everything happens. What must happen to keep our universe in an orderly operating optimal process. And when you have uh, um, this inequality of what you would call uh, um, a difference in the ratio, then you're going to run into either a universe that is like crazy hot or just crazy cold. And this constant appears everywhere in just about any process that involves uh, from anything from combustion to um, even things at the quantum level, apparently, and uh, you know, and and that's that. So, uh, I think this has kind of been an interesting kind of like for me, like it was kind of a eureka moment. Maybe, maybe not. I don't know what you guys would think of this. But anyway, thank you for listening to my crazy ramblings. And I think I've pretty much got the one at least what that represents, and I put that as my symbol that I made up, and this is actually the letter F in Cyrillic, and I put that as like the force of energy or um, force of motion, any force of matter. Um, Energy is matter. So, anyway, once again, thank you for listening to this crazy ramblings, and hopefully, I've come maybe at least a millimeter, a millimeter closer to solving this crazy riddle that's befuddled every physicist known to history. And this is Eric Lee signing off. Thank you very much. I'll see you in the next video. Thank you. Bye bye.